Hello everyone, welcome to IGBits. We train and you learn. So today we shall start our mathematics revision class topic integration, indefinite integration. Without further delay, we shall start. I hope you are all doing good and then your learning going in good direction. Let's see. We created a YouTube channel which does that our YouTube channel at the rate IGBits. Feel free to subscribe the channel. We started uploading all our sessions in YouTube. You can utilize this opportunity and build your competency. All right. Yeah, thank you. Let's look at integral of power function. What it means: integration x to the power of 1 dx. How do you rewrite? X to the power of n plus 1 by n plus 1 plus constant, where n equal to, when not equal to, minus 1 and c is a constant value. So how do you apply this into the formula? This is a basic thing, right? So I'm sure I think we are all should know. Let's say our given problem is x to the power of 5 dx. So we are asking for the integration. How much? This is in the form of x to the power of n. So what is n value here? N would be the 5. So the answer would be now how much? X to the power of n. So x to the power of 5 plus 1 divided by 5 plus 1 plus some constant. So what would be x to the power of 6 by 6 plus c would be your answer, right? Good. So likewise, I think you can solve many problems. Let's say I have one more problem statement stating that x to the power of 3 by x to the power of 2 dx. What makes difference, right? This anyway we know, integration of x to the power of 3 into x to the power of minus 2 dx. This also nothing but what? X to the power of 3 minus 2 dx, right? X to the power of 3 minus 2 means like x only, x dx, right? X dx means like x power 1. So the answer would be x to the power of n plus 1. So 1 plus 1. Here n equal to 1. So x to the power of 1 plus 1 by 1 plus 1. This implies x square by 2 plus some constant would be your answer. So likewise, I think you should be able to solve the problems. This is simple thing, and but this you widely using in our other subset of the problem solutions. Basic rules of integration. We have case 1, case 2 and case 3. What is the case 1 that talks about? Let me get my pen. So case 1 is integration of k dx equal to kx plus c. When k is a constant and then is function of dx. K dx means you can take out the k from the integration and then do the rest. So what that means is, let's look at this integration of 3 dx. What you are saying is like 3 is a constant, so you are taken out from the integration and then just do the dx. Dx is nothing but 1 dx, right? So 1 dx. So in that case, is 1 dx is nothing but x. You have to apply. So x plus c. That's what the answer. Okay. If you look at case 2, k f of x dx equal to k integration of f of x, means you are taking k out from the integration and then do the integration only for f of x. This is like a second case. Let's think about the case integration of 3x dx. How we are doing this one? You take now 3 out and x dx. You know what is meant by x dx? X to the power of n plus 1, right? 1 plus 1 by 1 plus 1 plus c. So 3 x to the power of 2 by 2 plus c. Correct now? This is the solution. And case number 3, now you take out. Let's say you have two functions like this, f of x and g of x of dx. Then you can apply the integration individually. That means like integration can be applied to the f of x dx plus and function g of x. This is what it is. You can think of even this also. Let's say you have 3x plus and then log x of dx, right, from integration. This is like an f of x g of x function method. So what you have to do, like 3x dx plus integration of log x dx. This is how you have to apply. So rules, right? Case 1, case 2, case 3 is widely used in our integration problem solution. Adena? Yeah, you have to remember. So let's look at integration, right? Indefinite integration of standard forms. Okay, x to the power of n dx. Integration of x to the power of dx. How do you write it? X to the power of n plus 1 by n plus 1 plus c, constant. Integration of a power x dx. How do you write it? A power x by log a plus constant. Integration of e power x. How do you write it? E to the power of x plus c would be the integration of e power x. Integration of 1 by x dx means log x plus c, right? So let's see this trigonometric equations. I think I have one typo that I have to correct it. Let me take out my pen. So integration of sin x dx is nothing but plus, how much, like minus cos x dx. This is right only integration, no? Integration of sin x dx is minus cos x plus c. Integration of cos x is nothing but a sin x plus c. Constant is always there. Constant. So we termed as a c. Integration of secant square x dx. This is like a tan x plus c. Tan x. Integration of cosecant square dx minus cot x plus c. So secant square, cosecant square. When it comes, then you will see the tan x and cot x. Secant x tan x, the product of secant x tan x dx for integration, right? This is nothing but secant x plus c. Similarly, integration of to cosecant x cot x dx. This means minus cosecant x plus c. So if you remember these things, right, while doing the integration, you should be able to actually answer this question so easily. So that's an idea, when you do this. So let's say, for example, your problem statement is given is like integration of sin x plus cos x dx. See, from our rule number 1, this integration can be applied to the individual terms, f of x, g of x terminology. So like integration of sin x plus integration of cos x, right, dx. So now you see integration of sin x means like how much? Minus cos x. So you put minus cos x plus integration of cos x is nothing but sin x. You put sin x, right? And then some constant always goes. This is how you can apply the things. And then other inverse functions also we have. So integration of 1 by root over 1 minus x square dx. This is nothing but sin inverse x, because for sin x, what you see, sin x is nothing but 1 by root over 1 minus x square. Now in this case, inverse function, sin inverse x. Similarly, integration of 1 plus x square, 1 by 1 plus x square. This is a tan function. So tan inverse x plus c would be your answer. Or also you can say like minus cot inverse x, sin inverse x or minus cos inverse x, or tan inverse or minus cot inverse. Similarly, integration of 1 by modulus of x root over x square minus 1 dx. When you have this is straight away secant square x plus c, or minus cosecant square, cosecant inverse, right? Secant inverse or cosecant inverse, minus cosecant inverse plus c. That is how I read it. Okay. So these formulas are very essential for us to remember for solving while solving integration problems. Okay, let's look at these formulas. Integration of 1 by x. What you see is like 1 by x is nothing but a log x. Okay, whenever you see in your problem left with 1 by x integration, that means like it's a log x plus constant. You don't need to write constant fully, but you put c also. Now integration of 1 by ax plus b form into dx. How do you see this one? this is nothing but 1 by x similarity. So you take this all t, then what you have to see is like this constant becomes like look like this way. So 1 by a x coefficient should becomes always like a forming this form 1 by a into log ax plus b, because this all, if you say some kind of an let's say this ax plus b is equal to t, then if you can convert this function, this becomes like 1 by x dx, this form. So the how you would write it, I would be writing 1 by a log ax modulus of ax plus b into c. This is what you can write. So let's say for example you have integration of 1 by 2x plus 3 dx. You don't need to worry. So when you look at this one, it is nothing but 1 by x dx form. So x coefficient is how much? 2, right? So you have to say 1 by 2 and then apply log only, log 2x plus 3 plus c, then your answer. Okay, that's what it's saying. Similarly, see, integration of e power x dx is equal e power x plus c. That is how we read in the previous slide. Here there is a constant. When you have this constant and a multiplied by and x coefficient, right? A is a constant per as a coefficient to the x, right? A multiplied by x. This constant can be written as 1 by a power x plus c. So let's say you have e power 3x dx. How do you write it? In terms, in place of a you have number 3, right? Constant value. So if you apply this formula, 1 by 3 e power 3x plus c, that is how you have to write it. You got it? So this what right we've been using and solving the problems. Let's look at in this case now. Previously what we have seen, sine, cos, secant square, cosecant square x, secant square x, cos square x as a function of x. But now we are actually applying, instead of x we are saying ax plus b like that. So now do you solve them? So only difference you see, like what is the multiplication of x coefficient at a? The a would be becomes like 1 by a and apply the function. So sine means like minus cos, cos means minus sine, cos means like plus sine, secant square means like a tan, cosecant square minus cot, secant means secant x, secant tan means this is tan, right? Secant tan means like secant, cosecant cot means like minus cosecant, but whatever the constant which is multiplied by x, right, that value becomes like 1 by, right? If it's 2x is 2x, 4x 4, something like that. Let's say for example you have sine 2x plus 3 of dx. How do you write it? This one, by apply this rule, sine function becomes like a minus cos function in integration, that anyway will come, right? But what is the coefficient for x? It's 2, right? Well, then 1 by 2. In place of a we have 2. So 1 by a place, in place of 1 by a we are saying like rewriting 1 by 2. Apply cos ax plus b means like 2x plus 3 plus constant c, right? 2x plus 3 of cos plus c. This is what you will get it, right? Likewise you can solve the problems. I hope you are clear. Let's look at this one. A substitution method. So if you given problem statement is in the form of integration of f dash x by f of x dx. So f of x ka differentiation is like f dash x. If you see so, then you would imagine this becomes like integration 1 by t of dt. If you convert a x in terms of a t function, then it looks like a 1 by t of dt. If you see 1 by t or 1 dt or 1 by x of dx, what happens? Log x or log t, right? That is what you see. Integration of 1 by x dx, it is nothing but is log x. We studied. So now you rewrite, instead of x you can put a t, integration of 1 by t dt, function of dt. Then you say like a log t plus c. You have to just apply but the basic thumb rule remains same, right? That is how it is. But what we are saying, f of x f dash x. So differentiation of f of x is nothing but f dash x. How do you write it? F dash x means d of dx of f of x. This is our right. So let's take this example. You take this is f of x bottom, right? So and then you can differentiate this one d of, and if you say t equal to 3x square minus 2, then apply dt by dx. How much? So you have to apply differentiation of dx 3x square minus 2, right? And then differentiation means like what is the formula? If d of dx of x power n, in integration you are raising power, here you are reducing the power, n into x to the power of n minus 1. This is how your formula, right? So 3 into x square, you take 3 is a constant, apply x square for this formula, n place we have 2, then 2 into x to the power of 2 minus 1, this is 1, right? And minus, for differentiation for constant, right? D of dx of k is nothing but 0. For constant we don't have anything, this becomes 0. So what we have is that 3 into 2 6x. So dt by dx is equal to 6x. So dt means 6x dx. Correct now? Then you apply for a given problem statement. How do you apply for this one? Integration of 6x plus 6x by 3x minus 2 dx. Correct no? So 6x dx is nothing but dt. So put a dt. And then 1 by 3x square minus 2, what we say is t, let's say t, 1 by t. So 1 by t dt is nothing but log t. So you are applying log t dt. What is t here? What is t here? What is t? So because here we are assuming let t equal to 3x square minus 2. So we have to replace now 3x square minus 2. Do you see this one? So denominator becomes like your log of that denominator is what it is. When for a given problem in the form of integration of f dash x by f of x, then you can straight away apply this formula. Clear? See, in indefinite integration of standard formulas, we have a few more hyperbolic, formulas. We have to remember this also. Sometimes like they're asking like hyperbolic related integration problems also. So let's run through one more time. Integration of sin hx dx is nothing but cos hx plus c. Integration of cos hx dx is nothing but sin hx plus c. Integration of secant h square x plus dx is nothing but a tan hx plus c. The first three functions we have all positives. And then let's look at next three. Integration of cosecant h square x dx is nothing but minus cot h x plus c. Integration of secant hx tan hx, this is nothing but minus secant x. Integration of cosecant hx cot hx dx, this is nothing but minus cosecant hx plus c. These are the formulas. Little tricky, hyperbolic versus non-hyperbolic, that in the sign sense that you got to remember. So one more thing is like inverse function, right? In inverse also, 1 by root over 1 minus x square. If you say that like that's a sin inverse x. Whereas hyperbolic function, this becomes like a plus 1 by root over 1 plus x square. When you see this, then you can think of this is a sin h inverse x because of the plus sign. Right? You can also rewrite them log of x plus root over x square plus 1. Similarly, 1 by root over x square minus 1x. This is nothing but now cos h inverse x. Right? You can also rewrite in the log function, log of x plus root over x square minus 1 plus c. Right? These are also very important, and we have to remember them. Okay, let's try this function. Integration of tan x dx. How do you write this one? So we know that tan x means how much? Tan x in terms of sin x cos x, so sin x by cos x. Correct no? So let's write it sin x over cos x dx. If you say this is in the form of f dash x by f of x form, think about it. It's nothing but log of f of x plus c. That is how it is, the formula. So if t equal to cos x and dt equal to minus sin x dx. So minus dt equal to sin x dx. So if you know this, the straight function, right? So what you have to see, minus dt divided by t. So minus integration of 1 by t dt, it is nothing but log t. So minus log t, log, what is t value? T means like cos x, log of cos x plus c, right? This is how you can solve. See how easy it is. Let's try out this one. Integration of cos cube x sin x dx. This is again a substitution method. What you have to see, like you have to figure out like which one you have to say function t, right? So since this is a power, I would assume that I think we can, let's assume let t equal to cos x, then dt equal to minus sin x dx, right? So this you can replace with minus dt, and this whole cos cube x is nothing but a t cube, integration of t cube and then dt, minus is out. This is how you will write it now, rewrite this function. So we know this t cube x to the power of n integration, what is this means, x to the power of n plus 1 by n plus 1, agree? So minus t to the power of n plus 1, rising 1, right? 3 means it become 4 by 4 plus c. What is t? T means cos x, right? So cos to the power of 4x by 4 plus c would be your answer. Clear, no? Good. Okay, let's solve this problem. This is looks like in the form of f dash x by f of x dx form. Straight away I can say answer would be log e power x plus 1 plus c. Okay, let me solve this problem. Let's assume t equal to e power x plus 1. Differentiate both sides. Dt equal to differentiate e for x is e power x plus 1 means like constant of dx, correct? So dt equal to e power x dx. You see, you can replace e power x dx is nothing but dt. So given problem now, I'm rewriting 1 by t dt. Clear? 1 by t dt is nothing but what? Log t, right? Plus constant. What about t? T means like e power x plus 1, right? This is what it is. So let's replace now. So log of e power x plus 1 of plus c. This is what answer. You know? Good. Very good. Integration of secant square x minus cos x plus x square of dx. This is a kind of a f of x dx plus g of x dx. So this is the form. So you apply integration individually. How do you rewrite this one? Integration of secant square x dx minus integration of cos x dx plus integration of x square dx. 3 subfunctions. You solve one by one. Integration of secant square x dx. This is nothing but tan x, right? Tan x. Cos x. Integration of cos x is nothing but sin x. Let's put a sin x. Plus integration of x square. What is the formula? Integration of x to the power of n, power function. So x to the power of n plus 1 by n plus 1, right? So we apply this one, x square. So you raise power by 1, x to the power of 3 by 3, and you add one constant. You don't need to apply for all C, C, C. It is a constant becomes constant, right? So this would be the formula. I mean your solution for given problem. Clear? All right. This problem statement shown on the screen, I would rather call it as a homework problem. I would like to see how many of you, going to solve this one. Okay, let's move on next. Whenever you see integration of secant x dx, so the expansion for integration of secant x dx is log secant x plus tan x plus constant. We can also rewrite them log tan pi by 4 plus x by 2 plus c. So you have to carefully see that what are the options given, and then you have to choose your solution accordingly. Right, this is one thing. Integration of dx by 1 minus x square. When you look at this one, this is like a sine inverse function. Remember. Similarly, integration of 1 by x into root over x square minus 1 dx. When you see this, this is nothing but secant inverse x plus c. Integration of 1 plus x square dx. When you have this means like this is a tan inverse. Right? These are the inverse functions. You have to just remember them. So now, so very broadly, what we are saying is what are the methods that we are using for the integration problem solution. We have a substitution method, by parts method, and partial fraction methods. So make use of these three. You should be able to solve all integration problems, indefinite integration problems. We will see more in the next session. You can solve this problem. This is 1 minute problem. Sin to the power 4x dx by cos to the power of 6x dx. Okay, you try solve this. Hint is, let's convert sine cos in terms of like a tan secant. Right? Rewrite this one. Rewrite in terms of tan secant functions. Then you can solve it. We can solve it. So this would be our homework. Try out this one as well. Integration of x to the power of 6 divided by 1 plus x to the power of 14 dx. I'm sure you should be able to find out the solution for this too. I would be call this as a homework problem. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. We reached the end of session. Thanks for all who are actually joined today's class. I hope this class is useful. Try to spend some time, quality time in your preparation. Okay. Stay tuned to next session. See you tomorrow, guys. Okay. Have a good day.